This video presents a utility patch, built around the Carousel module of Count Modular, which has the function of generating arpeggios around a sequence of chosen chords. Unlike specially dedicated modules, the skeleton as well as the rhythm of the arpeggios are configured by the patch. First, here are some sound examples of its possibilities. First, I would like to mention a problem that is often encountered in patches using a clock to control a sequencer. Indeed, it often happens that after a reset, the clock restarts the sequencer immediately from the second step, thus ignoring the first sequencing step. So, I quickly explain, first of all, an alternative method of creating a clock and its dividers in order to get around this problem. This clock device also has the advantage of a very easy and fast configuration of the rhythm of the arpeggios created. To begin, let's do a quick reminder of how this clock works. The core of the clock includes a gate delay module and an edge module. The output of gate delay is patched to the input of edge. The fall output of the latter is patched to the gate in input of gate delay. Also, as soon as a falling edge is detected by edge, a trigger is sent to gate delay, which leads the latter module to send a signal again to edge. We have thus created a perpetual movement which generates triggers at regular intervals. To start the cycle, we need to send a first trigger to the gate delay input, which will be done by an MK3 module. In order to interrupt or re-establish this cycle, a start-stop device constituted by a SW switch from Carousel is inserted in the connection between fall and gate in. We can visualize the various effects of the montage on a scope. The signal taken from out of gate delay is a square wave. Using the delay and width potentiometers of this module, it is possible to modify the widths of the signal in the high state and in the low state. We also see that a trigger is emitted at regular intervals on the fall output of the edge module. It is this clock signal that we will use to control sequencing. If you want to see in real time what clock frequency the delay and width settings correspond to, you simply need to patch a BPM delay module. The latter will display the number of beats per minute. We will now equip our clock with a divider device using a pulses module from Artificial Colors. This module counts the number of triggers received on its step input and sends a trigger on its out output as soon as this number reaches the number defined by the user by the out-on potentiometer. If, for example, out-on is set to 4, a trigger will be sent by pulses on out as soon as it has received 4 triggers on its step input. For this to be done periodically, the loop button on the module must be activated by clicking. We see that these triggers are in a ratio of 4. In other words, we now have, on out, a clock signal with a frequency equal to a quarter of the frequency delivered on the fall output of edge. So, by duplicating the pulses module as many times as necessary, you can obtain as many devices as desired and with any denominator. Now let's see a patch using our clock and its dividers. The chords of our series are generated by the interior module. The voltage corresponding to the root note of the chord to be created is patched to the volt octave input of interior. In our example, it is a G in the third octave. We then choose the type of chord, which can be major, minor, dominant seventh, or diminished seventh. We also choose the reversal that interests us, fundamental state, first, second, or third reversal. Finally, you can also choose the voicing. Depending on these choices, interior generates 4 ratings on its outputs. This is the root note of the chord, its third, its fifth, and the seventh. The reftone module will allow us to enter the root of the chord, which will be generated by the interior module. At its output, we take the root of the chord, the third and the fifth, and via the octave modules, each of these notes is raised by an octave. We will see how these 6 notes can be used, in whole or in part, to arpeggiate the chord. In order to memorize and sequence the series of chords that interests us, we use the 8-face module. The latter is therefore associated with the reftone and interior modules via its context menu. I remind you that the methods of using the 8-face module and, in particular, the procedures for sequencing and storing presets in memory are the subject of a previous video to which we can refer for more details. We can now memorize our chord sequence. For the example, I propose a series of chords that I write on the screen. For each of these chords, interior allows us to enter the type, major or minor for example, as well as the inversion and voicing. Let's now see how to arpeggiate the notes produced at the output of the interior module. For this, we use the Carousel module from Count Modular, to whose inputs we patch the notes produced by interior. How Carousel works is illustrated by the montage displayed on the screen. Carousel has 8 inputs in 1 to in 8 and 8 outputs out 1 to out 8. Each signal patched to a carousel in is sent to the corresponding out. Thus, the signal patched to in 1 is sent to out 1. The signal patched to in 2 is sent to out 2, and so on. Receiving a trigger, either on the up input or on the down input, will cause a rotation of the signals present on the out outputs. This shift will be done upwards if a trigger is received by up, and downwards if the trigger is received by down. For example, after receiving a trigger via down, the signal that was present on out 1 is routed to out 2, the one that was present on out 2 is now transmitted to out 3, and so on. A trigger received by up will cause the opposite effect. The signal present on out 4 will be found on out 3, that present on out 3 will be found on out 2, and so on. We load Carousel into our patch and we patch the notes of our arpeggio to its inputs in the order in which we wish to arpeggio them. It is possible to repeat notes in the same arpeggio. In our example, the order of the arpeggiated notes is displayed on the screen. We want one note of the arpeggio to be played at each clock pulse. So, we patch the fall output of the edge module, which is our clock output, to the up input of Carousel. So at each clock pulse, Carousel will rotate the notes of the arpeggio. The delay and width buttons of gate delay also allow us to adjust the duration of each note. Furthermore, we want to change chords when the arpeggio notes have been played. To do this, we patch the out output of pulses to the CV input of 8-face. Since our arpeggio has 6 notes, the out on output of pulses is set to 6. In this way, every 6 clock pulses sends a trigger to 8-face and the latter moves to the next chord. To test our device, we load a complete audio chain. For the example, the VCO is an XFX wave module. Its octave volt input is patched to the out1 output of Carousel, and the out output of gate delay is patched to the gate input of the envelope generator. It is now possible to complete the device with a VCO to accompany the arpeggios. To do this, we must first patch the outputs of the interior module to the inputs of a merge module, which delivers a polyphonic signal at its output. This signal is patched to the volt octave input of the VCO dedicated to chords. For the example, we load the palette module. The associated envelope generator is controlled by the out output of pulses, which allows us to set the envelope length to the duration of a chord. Our patch is now operational. Note that the arpeggio sequence can be increased to 64 chords using +8 extensions from 8 face. Furthermore, the number of notes per arpeggio can vary between 2 and 8, with note durations configurable by gate delay. One way to introduce variations into the arpeggios is to reverse the order of the arpeggiated notes by alternating the carousel rotation modes after a predefined number of chords, which will be determined by the out-on button of a second pulse module. This pulses module will receive on its step input the tuning change triggers coming from the clock divider. It will send a trigger to its out output after the number of chords we have chosen to switch from one mode to another. The toggle input of a SW switch is patched to the pulses output. The out outputs of the switch are then connected to carousel, one to up and the other to down. Finally, the in input of the switch receives the triggers coming from our clock, which are taken from the fall output of the edge module. The pulses module is positioned in loop mode. In order to test the effect obtained and make it more audible, a new sequence of arpeggios composed of 6 notes and limited to 4 chords is memorized by 8 face. We decide to switch from up to down each time the sequence restarts, i.e. every 4 chords also. The out-on button of the pulses module is set to 4. Another way to modify the arpeggio is to introduce a delay on the up and down inputs of carousel. It is on these last notes that this video ends. Thank you for agreeing to follow me on this brief tour of the Planet VCV Rack.